Hello everyone, welcome to day 30th of January LeetCode challenge, and I hope all of you are having a great time. The question that we have in today is rotate array. Here in this question we are given an array of integers and an integer value k. We need to return an updated array such that each element is moved ahead by k units. For example, here the input array is given to us as 1, 2, 3, 4, 5, 6, 7 and the integer value that is given to us is as 3. So we need to make sure that each element moves ahead by or gets rotated by 3 units. As a result of which 1 moves to the 4th position, 2 moves to the 5th position, 3 moves to the 6th position and 4 moves to the 7th position. For the remaining elements 5, 6, 7, as the elements gets rotated, they move to the initial starting position 0, 1 and 2. Without further ado, let's quickly walk through the solution that I have created for this, and I'll be talking about two approaches. One to do in order of n times space complexity, the other one where we'll be using constant space. So do have a look at both the solutions. Let's quickly move on to the PPT. Rotate array LeetCode 189. It's a medium level question on LeetCode. However, I feel it's an easy question. So let's get started with the naive or the first approach that comes to everybody's mind, where we will be using an extra space to actually form the resultant array. Let's take the same example that was specified in the question. We have the elements as 1, 2, 3, 4, 5, 6, 7 and the value of k happens to be 3. So what you can do, you can simply create a new array and start copy pasting all the elements up till total minus k. So that would be equal to 7 minus 3, that is 4. So you need to copy paste all the first 4 elements to I plus k position. So what is I plus k for this? This 0 plus 3 gives us 3. That means 1 moves to this particular location. Similarly, 2 moves to 1 plus 3 gives us 4, this particular location. So let's keep writing that as well. 3 moves to 2 plus 3 location, which is this one, 5, and 4 moves to 3 plus 3 location, which is nothing but this one, given as 6 index. So right now we have filled in the first 4 elements appropriately, and for the remaining ones it's pretty simple and straightforward. You can start the iteration and you can take a pointer and start filling the remaining elements starting from k up till length minus 1, total minus 1. So these will be filled at the starting of the resultant array. So let's do it. 4 gets here, 5 gets here, 6 gets here and 7 gets here. You can start a counter starting from this particular location and iterate up till the last. Pretty simple and straightforward. Nothing rocket science in this. However, the time complexity of this approach is order of n, since you are iterating through the input array only once. Also, you have used an extra space for building up your resultant array. Can we do something better than this? Can we do it in constant space? The answer is yes. How? Let me just show that to you. In the first go, what I'm gonna do, I'm gonna reverse the complete array. So the complete array gets reversed. The elements get set as 7, 6, 5, 4, 3, 2, 1. In the second step, what I'm gonna do, I'll take the first k elements, that means 0, 1, 2, and I'm gonna switch this over. I'm again gonna reverse these elements. So the updated array turns out to be 5, 6, 7, 4, 3, 2, 1. And finally, in the last step, what I'm gonna do, I'll reverse the remaining total minus k elements that are represented over here, 4, 3, 2, 1, and the resultant array after the reversal would be equal to 5, 6, 7, 1, 2, 3, 4, which is in sync with our expectation. So what is the first step? You reverse your entire array, then you reverse a portion of first k elements starting from 0 up till k minus 1, and in the next step what you're gonna do, you're gonna reverse all the elements starting from k index up till total minus 1. 3 simple steps, and in each step we are doing nothing but reversal. So the time complexity of this approach turns out to be order of 2n. Why 2n? So in the first step you are reversing the entire array, and in the second step you are reversing it in portions, as a result of which you are doing it 2 times, but overall complexity would remain the same, which is nothing but order of n. In terms of space, we are not using any extra space, so the space complexity turns out to be order of n. Let's quickly walk through the coding section and conclude this question. in the first step, what I'm doing, I'm taking k equals to k modulus the number of elements that I have. Why I am doing this? Because think of the case where k happens to be 100 and the length of the elements happens to be 3. Then I only need to rotate this only by 1 unit, because 100 modulus 3 will lead to 1. So that's why I have done k equals to k modulus length. And in the first step, I have created a helper method, which is basically reversing the elements start from the starting position till the ending position in place. And I go for the reversal of the complete array first, then up till starting from 0 up till k minus 1, and then from k minus 1 up till total minus 1. And once we are done with this, let's try and submit this up. This helper method is pretty simple and straightforward. I think most of you will be able to write by yourself. The runtime is 1 millisecond, which is pretty good. The time complexity happens to be order of n, and space complexity is constant space. I hope you enjoyed today's session. If you did, please don't forget to like, share, and subscribe to the channel. Thanks for viewing it. Have a great day ahead and stay tuned for more updates from Coding Decoded. I'll see you tomorrow with another fresh question. But till then, good.